Okay, so before we jump into other stuff, so let's see, geometry. There was a summer packet. It's going to be due on Monday, and we're going to have a quiz on it on Monday. Should be review, I hope. If it's not review, we need to talk. Let's talk about any questions you might have come across on the summer packet. And what I'll do is I'm going to go down here, and we're going to add a slide. I'm going to do that. Insert. Okay. Yeah.
So for the first worksheet,
Uh-huh.
on numbers 3, 8, and 9.
3, 8, 9. Can I borrow yours?
Yeah.
I'm just going to write them right up on the board. That's cool. I'll give it back to you, okay?
Yeah.
3,
There's a variable, but for
8, and 9.
yes, but for the answer on the answer key, it doesn't have a variable.
We might have made a mistake. Oh, you know what? So there's a G in there. I don't think that G is supposed to be there.
And there's like.
Okay, so I'm going to put a question mark there.
Okay.
That's kind of what they have for that problem. That was a G, and let's see, number 8, that's a mistake, and number 9, that's also a mistake. Those G's should not have been there. I apologize. What else you got? Other questions? There was, so on that page 1, the G that was on those particular problems was a typographical error, showed up on the internet. We probably put it there just to mess with you guys in June when you probably looked at this first time. What do you got? More?
Yeah.
More letters?
No, but for on worksheet number 6, 3 and 16.
Okay. Borrowing yours again. 3 and 16. And this is on page 15 at the bottom, right?
Yeah.
Number 3, 2x, x squared minus 8x plus 1. And number 16, 2d plus 3, 3d plus 1. There you go. First one, what are we going to do? It's property. Distribute, absolutely. So I'm going to distribute here, here, and here. It has to go to all three terms. 2x times x to the second becomes 2x to the third. Exponent, when you're adding exponents, or you're multiplying, and there's exponents involved, you add the exponents together. And then, so the minus comes along for the ride. 2x times 8x is 16x squared. And then 2x times positive 1 is just 2x. And that's done, though. You cannot combine the unlike information. Yeah?
The answer key said, instead of minus 16x squared, it said minus 8x squared.
That was a typo on our part. We're just preparing you for college when you get those answer keys that the TAs wrote. There were a lot of answers wrong.
And then I think the same thing happened on 16.
Okay, so I would say that that would be 6d squared plus 11d plus 3.
Yep.
Answer key wrong.
6d squared plus 11d plus 4.
They goofed up. Our error again. Yes, ma'am.
Page 8, number 20.
I'm going to borrow yours real quick, if that's all right. Page 8, number 20. This is page 8, number 20. X minus 4 over 2x plus 1 equals 3 over 5. And they have an answer of negative 23. So it might be a goofy answer. Let's do this. Let's dim the lights and keep this backlight light on. I know you probably can see it pretty good, but on camera it really captures the moment so much better. Where's our first step on starting this problem? And granted, the answer key might be incorrect. Well, the one math teacher might have told you it's the product of the means is equal to the product of the extremes. You're like, huh? Cross multiply. Right? So I'm just going to If those are brackets or parentheses, cross multiply. So I have 5 times quantity x minus 4 is equal to 3, 2x plus 1. Things you should think about on this problem. This is an algebra 1 concept. Your denominator in one of your parts could create something that isn't true as far as the solution. Because if that denominator becomes 0, that's a bad thing. So things you should think about is you have to know that that's negative 1/2, I'm sorry. My answer cannot be equal to this. And the reason it can't be equal to that is that if I plug negative 1/2 into the original blue problem, my denominator on the left side becomes 0. That means I'm dividing by 0, which is an undefined term. So that's the first little thing that you kind of should think about a little bit, but you might not have to approach. And then we can go ahead and work out this problem. So distribute 5x minus 20, 6x plus 3. I'm going to subtract the 5x, bring it over. That gives me x over here. Still with me? I can subtract the 3, bring it over here. X equals negative 23. And if those of you missed that, here's the math that took place. I subtracted 5x from both sides. I could have subtracted the 6x, and then I had a negative variable, but I could have moved it. And then being I brought this over, I'm going to bring this over by subtracting it. And that's the math that took place. Of course, x equals negative 23 is also very acceptable. Was that the answer, the correct answer in the solution guide?
Yeah.
Do you see an error you might have made?
Yeah, I just didn't know how to start it.
Okay. And one last thing. Does it make sense that we need to think about sometimes a solution can't exist because the denominator could become 0? Other places you might see that would be if you had a square root or a radical, and inside that radical happens to be an x. Okay? Does that make sense? Other questions we've come across on some pack.
Worksheet number 4.
Or number 1. Worksheet 4, number 1. I'm sorry, you said what?
My answer just didn't match up with one of the answers.
It's very possible we made errors. All right, find the slope of the line passing through the given points. Perfect. So slope equation is the change in y over the change in x, or it's m equals y2 minus y1 equals x2. So this is a go-to from Algebra 1. Do you recognize that? The change in the y values over the change in the x values. I could have had y1, y2 as long as this was x1, x2. So it's not imperative. I like to label because I'm off task often. And then our slope, we're going to go y2, which is 1, subtracting y1, which happens to be 5, over x2, which is negative 7, subtracting negative 5. That means on top, it looks like I'm going to get a negative 4. And on bottom, the negative in a row becomes positive, so that becomes a negative 2, I believe. This reduces to positive, goes to 2 over 1 as a reduced, which you could also have an answer of 2. Was that what the...
Yeah, I
okay.
made a dumb mistake. Sorry.
Life happens, I understand. Is there other questions that come off of the packet? Yeah.
Worksheet number 3, number 16.
316? Thank you. It's on page 8, number 16. So 2, quantity x minus 3 minus 4 equals 8 minus 2 quantity x minus 4. Okay. We don't have any variables in the denominator, so we don't have to think about anything silly might happen. Or order of operations suggests I multiply that. And I bet you I'm going to find your error here in a second. You probably agree with me here. No? Yes? 2 times x is 2x. 2 times negative 3 is negative 6. The negative 4 comes along for the ride. Still with me? That's going to be where so many errors take place. 8 comes along for the ride. What am I distributing over those parentheses? -2. So this -2, this whole thing has to come along for the right. So -2 times x is -2x. And then -2 times -4 is +8. Did I find your error? Okay. Does that make sense? Okay. And then if I just work out the rest, that's 2x minus 10 equals 16 minus 2x. So I'm going to add 2x, so I get 4x over here. I'm going to add 10, so I get a 26 over here. And x is equal to 26 over 4, because I would divide it, and that gives me 13 over 2. Is that okay? Cool. What else? A-okay? Life good? Yeah.
Okay, I don't want to use like too much help with this, but can we just go over like the inequalities and graphs and then
Mhm.
just do like a random
Perfect.
problem?
A random one? Can I take this thing up and you pick one? 14? Okay. So this, let's up in this back here. This is page 10, number 14. So remember the page number's at the bottom. Okay, so it's a linear equation, so it means it's going to graph a straight line. So the concept of y equals mx plus b completely works on this one, where we have a y-intercept that we find, and then we use the slope to find another point. But then, because it's the inequality, we have a few things that we're going to test for. This would be, on a test, probably a 3-point problem. Okay? A place that a lot of kids will miss the point. Well, if you graph it incorrectly, there's your first error. This is a solid line, not a dotted line. Okay, so remember, solid lines come when you have this or this. That's solid. I can't spell, that's soiled. And if you had this or this, that's dotted. Okay? So so is this going to be solid or dotted? Solid, okay. And then we have to, let's go ahead and graph our linear equation. I don't have my grid up there. I'll have to make a graph later. All right, so xy axis, y-intercept is -1. Yay. What's the slope? -1. So our slope is right there. So the slope is -1 over 1. So from this point, I'm going to go down 1. And then I'm going to do what? Go right 1. And we said this was solid or dotted? Solid. So that gets you 2 out of the 3 points right there. The last step on this problem would be you need to figure out which region to shade. You have a region that is above the line, and you have a region below the line. Do you agree? What looks like a fantastic point of the infinite numbers out there? What would be a fantastic point, an x comma y point, to pick to test? 0, 0. The line does not go through 0, 0. 0, 0 is definitely, this region right here is definitely, do you agree, up here? So if we plug in 0, 0 as a test, that means and if it happens to be true, that would mean any line up here or any dot up here would be true. If this gives me a false, that means any xy point up here would be false, so I would shade this part of the graph. Okay, so 0, 0 is a great test point. If 0, 0 doesn't work, pick something else that the line doesn't go through. Okay, so if our line happened to go right through the origin, then we have to pick another point. I like to pick points that are out on the x-axis in any direction. If possible, keep them both positive, because you don't want to make a silly sign error. So our test point, that's an x, that's a y. So the y value is going in there, the x value is going in there. I get 0 is less than or equal to -0 minus 1. What's -0? 0. Is 0 less than or equal to -1? Before you answer, would you rather have 0 debt or owe someone $1? 0 debt. So is 0 less than -1? Is that true or false? It's false. This is false. And this is a lot of times in computer software, this might be the type of if-then-else statements that might take place in C programming or Pascal and things like that. So that means that this point up here, everything that's above here created a false scenario. Okay? So let's see what we can do here. Let's go. We got anything cool? Oh yeah, we gotta go with the crayon. Heck yeah, let's use the crayon. So that means that, let's go with the crayon bigger. Okay. That means we shade down here because that region down here is appropriate. Now, guys and girls, there's always the one kid in class, and you know who you are. During the test, this is what you hear. Do you have an eraser I can have? No, it's the one kid who's coloring nonstop because, shading means something to them. You don't need to color in so much. And you always get that one kid who wants the eraser and his pencil is down to the metal part. You know what that sounds like with paper? He is just, yeah. We don't have chalkboards any longer because, the nails on the chalkboard was like irritating. The eraser that is almost completely out, that hits metal to paper on desk, woo-hoo-hoo! We love that. So, item 1, if you're the person that needs to shade nonstop, please, please, please make sure that you're shading the right region because I don't have an eraser big enough to take down the lead of 16 pencils that you just wasted shading in an appropriate region. Your region to shade, make it simple. Make it just real simple. Just be like, oh, it's like down here. Totally chill. I'm not grading you on art. You guys know the kid I was talking about? Nonsense. You're like, he's still shading. Yeah. It's been 15 minutes. He sharpened his pencil 12 times. And it's a mechanical pencil. I don't know what he's sharpening. Yeah, you get the one kid in class who's saying that. Was there any other questions that came from the summary packet? Yeah.
On worksheet number 7, which is page 17.
Yep.
One of them I have 6x squared.
What's wrong?
17.
Yep.
13.
13. I'm going to steal this from you real quick.
Good.
Number 13. Ooh, number 13. You should not use a calculator to complete this worksheet because we were watching. Factor the quadratic expression. Remember to check for common factors. Okay. This is going to lead into a little bit what we're doing today. So factoring, one of the other F words in math. Yay? You guys know the 4-letter F word in math, right? FOIL. And then the other one to undo FOIL is called factoring. So we have something called a second-degree polynomial. If we were to graph this, it is a parabola. Okay, no, we can't graph it because it's not y equals. He just spoke so fast. Okay? So we want to factor. We want to break this into 2 binomials, meaning what did we FOIL together? What 2 binomials did we FOIL together in order to get this? So first thing we're going to look at, does 6, 13, or 6 have any numbers in common other than 1 that we can factor out of all 3 of those? No. Do all 3 terms have an x? No. Is there a greatest common factor on this problem other than 1? No. That was item 1. Now item 2, and here comes the tough thing. Okay? How is he going to show factoring? Because there's a lot of ways to factor. And there's 3 kinds of people in the world. You guys know this. Those who can do math and those who can't. One got it. What's the 3rd kind? Sorry. Thank you guys for laughing at my bad jokes. So, how am I going to show factoring? Have any of you heard of the dream method for factoring? Raise your hand if you heard that method. And that's one you know, okay? How about the guess and check? How about the 90% rule? That means that 90% of the time, the closest two factors are the ones that are the factors, which I think is a good rule, but I also think, I don't know, it could be a gotcha thing later in life. I've actually seen this done using the quadratic formula and find the answers and work backwards, which is a whole different method. But the method I'm going to choose is this. Our magic number is positive 36. How did I get that? I multiplied the first term and the last term together. I didn't worry about the x's. You still with me in this adventure? Okay, now I'm going to take the factors of 36. Now, this is how I do it. If you do it your way that works and gets the same answer, please do it. So I know 1 times 36 is 36. Still with me? And I know that 2 times 18 is the way to get there. And I know that 3 times 12 is the way to get there. And 4 times 9 is the way to get there. And 6 times 6 is the way to get there. So then, those are all the factors of 36. Do you agree? Anyone go and do, how does 6 times 6 work or anything like that? Okay. Next thing I'm going to do is I have to understand that in order for me to get this to be a positive, I either have to have because that's my last term of FOIL, right? Which means I had to take a positive number times a positive number to get it, or a negative number and a negative number to get that to be positive. With what I just said, what do you think both signs have to be? Negative. Why? Yeah. That 13 is negative. That's exactly right. Okay? So, I'm going to create... I'm not going to do that yet. So I know that I have a negative and a negative. I'm just going to put negative and negative. That's going to tell me my answer at the end is going to both be negative. So I'm going to do this. 6x squared plus 6. Now we're going to do this middle section. We said that they both have to be negative in there, yes? So I'm going to go minus and minus. And I know I have an x and an x. Now minus x is minus 2x. That doesn't work. Of those factors up there, which two work, both being negative, that when I sum them together, I wind up with negative 13. Yes, ma'am? 4 and 9 is exactly right. Now, for those of you who are going, well, wait a minute. Okay, if these are both negative, this gives me negative 37. These both negative, negative 20, negative 15, negative 13, bingo, negative 12. Both of those have to be negative for this to work. We're almost done with the problem. We just had to find the combination that worked. Does everyone feel comfortable with that so far? Okay? What I'm going to do now is I'm going to start looking for my greatest common factor. So let's do purple. I'm going to look at these two, and then I'm going to look at these two. I split the problem into two parts. Feel okay? All right, what do I have in common between these two? What can I factor out of both? Yeah, a 2 and an x. Perfect. If I factor a 2 and an x out of 6x squared, what do I have left? 3x. Minus comes down for the ride. If I factor a 2x out of 4x, what do I have left? 2. Still with me? Oh, we're almost done. You're like, man, there's a lot of steps to this. I know. Anyone remember the rule? What has to take place if that's a negative right there? I know I have to have a negative term that comes out. What can I factor out of 9x and 6? What number? Yeah. 3. Okay, if I factor a negative 3 out of negative 9x, what do I have left? 3x. If I factor, trick question, negative 3 out of positive 6, what has to be left? Negative 2. This is usually where it's like, whoa, wait, where did that come from? Okay, realize this. Negative 3 times 3x is negative 9x. Agree? Negative 3 times negative 2 is positive 6. That's why you have to do that. Now, almost done with our factoring. So I went from 3 terms, I split 3 terms, to 4 terms, and I'm now down to 2 terms. Whoa. I have this, and I have this in common on both, yes? So if I factor 3x minus 2 out, I'm left with a 2x and a minus 3. That comes down for the ride. That's a combination of the dream method, combination of a few different methods. Which way works best for you? I mean, here's the long and short of it. Do the one that works best for you. And factoring is one of those milestones in your brain that your brain's going to grab it or it's not. There's nothing wrong with you if your brain hasn't grabbed it, you've mastered it. You have to understand that, okay? We good? Woo! Yes?
I have a question on the substitution method.
Oh boy. Okay.
Okay, so like I just like to remember
Okay.
number 11.
11. So this looks like it's coming off of page 14. Number 11. Page 14, number 11. 2x plus 3y is equal to 3. And I have x plus 5y is equal to 4. And did this indeed say use the substitution method to solve or elimination? Solve the following systems of equations using substitution method or the linear combination method. Remember to write your solution as an ordered pair to check for solutions. Okay. So you want to go with substitution? Did I give you that back to our first?
Yeah.
Okay.
I don't care.
All right.
I didn't remember.
Okay, so the substitution method, taking you back a few months, if you can solve for a letter easily, use it. So could I solve for a letter on either of those equations easily? And if so, which letter? Meaning, can I have x equals real easily or y equals real easily by adding or subtracting something to one of the equations? Which one would I like? Top or bottom? Bottom. Which one am I solving for? X. I can make this be this. Why is that? Yes, it's an equal sign. So if I do something to one side, if I go minus 5y minus 5y, this is what it comes into. Okay, so substitution might be a good choice on this problem because I could solve for one of the letters pretty easily. Okay, now with this known, I'm going to take this and I'm going to go into the other equation. I'm no longer using this bottom equation. I'm going to use this and I'm going to plug it in right there. I know that x is equal to this. I'm going to plug it into the other equation for x. So I get 2 quantity plus 3y equals 3. What was here originally? X. What am I going to put in place of x now? 4 minus 5y. 4 minus 5y. Okay? Here, let's make that a little nicer. Erase that. 4 minus 5y. Okay, distribute over the parentheses. 8 minus 10y plus 3y equals 3. Good. Let's combine any like terms. So 8's coming around for the ride for now. I'm going to get negative 7y equals 3. Subtract 8 from both sides. Just showing my work. So I get negative 7y is equal to negative 5. All right. 3 minus 8, negative 5. So y is equal to 5 over 7. This is a 4-point problem. You've now got 1 point. Did you solve for all variables? I've solved for y so far. I know approximately what x is equal to, but it's not a numeric value. So what should I do with this y value? Plug it back in. So here's the tough thing. Do I want to plug y into here? I'm doing it in yellow for a reason. What letter am I solving for right now once I plug y back in? X. Is there a modified equation that is x equals? Yeah, I modified the bottom equation to give me x equals 4 minus 5y. So I'm going to take this value here, what I just found, this y value, I'm going to plug it in for that. So that gives me x equals 4 minus 5 times 5 over 7. Ooh, x equals 4 minus 25 over 7. Ooh, yuck. Fiddlesticks. All right. Ready? What's the math I'm doing? 4 over 1 minus 25 over 7. I'm going to do this my way real quick. Some of you like kind of think, oh yeah. Plus make that negative. Still with me? 28 plus negative 25 over 7. 3 over 7. Sweet. So my answer is 3 over 7, comma 5 over 7. That's x comma y.
And then if you can't like get a variable by itself very easily, do you just like draw them on a graph? Is that how you?
You could draw them on a graph, absolutely. So I'm going to make one up, and it's just going to be ugly. The answer is going to become like ridiculous, and you guys are going to like beat me up in the hallway later. Okay? Let's say we had this. Okay? I can't get a letter by itself real easily. I mean, on the top equation, if I wanted to get y by itself, I'd have to subtract 5x and then divide everything by 2. Agreed? That's ugly. It's not pretty. So then the elimination method, or sometimes called the addition method, or the algebraic method. I mean, I don't know why they say, oh, it's the algebraic method. Well, we're doing algebra. Everything's algebraic. I don't know. Math people sometimes just don't have the most creative things. So then we have to say, okay, what letter do I want to get rid of first? Your question, you answer this. Do you want me to get rid of x or y first? Your choice.
X.
Good. There's no wrong answer to that. Unless you said 6, and you're like, no, x or y, not 6. Okay, so we're choosing to get rid of x. We're good? What is the smallest number that 5 and 7 have in common? Yeah, 35. So I'm going to multiply this whole thing by 7, this whole thing by 5. I have to pick one of them, either top or bottom, to be a negative number. Top or bottom, you check.
Bottom.
Bottom. So I'm going to make this one negative. All right, distribute here. So that gives me 35x plus 14y equals 42. Is that okay so far? All right, and then I'm going to do the same thing here. Whoop, whoop, but with the negative 5. So then that gives me negative 35x minus 30y equals negative 50. Is that okay? So now I'm going to add these together. If I add these together, what value goes bye-bye? 35. 35x is gone. You cancel each other out. It gives me 0. And then I add these together, and that gives me negative 16y is equal to negative 8. You got to be kidding me. So I wind up getting y equaled 1/2. That was a lot easier. I got so lucky on that. Jeez. I thought it was going to be like 38 77ths or something crazy. So that's my y value. Then what I would have to do with that is pick one of my originals, plug it back in here or here, which I'll pick the top one. That half of 2 is 1. Subtract that. Oh my gosh. How can I get 1 comma 1/2. I mean, an actual beautiful answer for winging a question. No applause is necessary, just throw money. But that's how you would do that kind of problem. So that's the elimination method or the addition method, or the incorrect version, I think people say, is the algebraic way. Cool? All right, let's put those away, please. So my gut tells me that we can do everything that would have been. Does anybody need a packet that I didn't get to? If you have your workbook, you're set. But does anyone need a packet that didn't have their workbook yet? I handed them out yesterday, but I ran out. So if you need them, come on up and just grab one off this pile real quick. I think there's one. There's one. Did someone else raise their hand? Okay, and there's yours. Okay, so let's just take a look at this packet real quick. And because it was my error yesterday, because I thought more people had the book, and I apologize. So I'm not going to make you responsible for worksheet 0.1 this very moment, but could you take a quick look at numbers 1 through 14, which I believe is the front page? Is there anything there that you're just a little bit confused about, and I need to go back over for you? So I'm just on worksheet 0.1. It's the first of your worksheets in your packet. And I'm sorry, there's not a page number at the bottom, but in the upper right-hand corner says worksheet 0.1. Is there anything on that very first page from 1 to 14 that you're stuck with. Are we okay? So if you had to get that done, you could get that done. And I think some of you actually have it done. Okay, can I flip the page? Let's go to the back side of that page. Or in your book, it might be the back side or it might be the next page. I don't know. I apologize. Next page. 15 through 18, we're just simplifying. Does anybody need help on any of 15 through 18 on that back side? I just want to take some baby steps down. 1920, got the 4-letter word there, oil. 21 through 29, any questions there? Any on 21 through 29? This is from 0.1 worksheet. Yes, sir. 29, perfect, I like it. 29 is a different type of problem because you have a radical. Still with me? So things that you should know right now, you can't have a square root of a negative number that gives you something that is in the real number system. Like, what? There's also the complex number system, which means that's where you have the I squared, the I to the third, I to the fourth, and then it repeats, meaning a square root of negative. So right now we know that x is not less than 0. Agree? Make sense? Okay, so let's solve this problem. If our answer comes out that way, it's something called an extraneous solution. And I don't know if we'll get there yet. But I'm going to add 5 to both sides. Still with me in this adventure? Which gives me this. Any thoughts on how to solve this last step? Go ahead. Square both sides. Awesome. So I'll square both sides. And that gives me x equal to 49. Now, guys and girls, as a high school student, it's really hard for me to convince you to do this last step. Because you're like, dude, that's more work. I'm sorry. But this is a gotcha kind of question. So all you really need to do is just do a quick check to see if it works. If I were to take square root of 49, plug it back in there, I get the square root of 49 rather than square root of x. What's the square root of 49? 7. Thank you for not saying plus or minus 7. Okay. 7. Is 7 minus 5 equal to 2? This is the solution to the problem. Okay? So that last step is what I have to convince you of. Anything else up through 29 on that sheet that's goofy? Yeah.
On 28.
28, okay?
It said that the answer was 4 -4. I'm confused why it's a point.
I got you. So this one, right?
Yeah.
So you're okay with this? Agree? So if I were to take the square root of each side, the square root of each side is basically doing the absolute value of how far from 0 are you. So this goes along with FOIL. There's so many things this goes along with. This is an excellent question because a lot of people are going to miss this. The answers are positive and negative 4. The reason why is this. If I went 4 times 4, I get 16. If I go negative 4 times negative 4, I also get positive 16. Do you agree with that? And this all relates back to the absolute value graph, which looks like a V. Okay, and that's really where this comes from. I'm not asking you to go there. I'm just trying to put that depth of knowledge with you on that. So your answer here should be a positive and negative 4. You could also write it this. You know, any of those answers are 100% appropriate. But that's why they both exist. And that's a great gotcha question. I would say you're going to see one like that on the quiz on Monday. Okay, it will have 2 answers. So if you have to take the square root of both sides, and this is where students are like, wait, you just told me on the problem before the square root of 49 is 7, but yet now you're telling me that I get 2 answers when I do. Yeah, if you do the square root of each side of the equal sign in order to get a variable by itself, you can come up with 2 answers. And it's normally a plus minus. Okay? Is there any other questions up through 32 now? 32. Anything? Anyone need to stretch? Punch your neighbor in the mouth? What's crazy? Spit? Yeah.
Wait, how do you simplify a radical again?
Simplifying a radical is this. If I had, like, say, root 50, if I had root 44, and I had root 48. Hard thing is most students want to say, oh, I can plug it in my calculator and get an answer. I get it, but that's called an irrational answer because the decimal goes forever. Break 50 into 25 times 2. The reason I'm breaking it 25 times 2 is 25 is a perfect square. Do you agree that 25 times 2 is 50? What's the square root of 25? And I don't know what the square root of 2 is, so that's my answer. So this one would break into 4 and 11. Square root of 4 is 2. Done. And then this is the tough one. Everyone wants to go with 4. Yeah, you're almost right, but it is 16 times 3. 16 is the largest perfect square, so the square root of 16 is 4, so I get 4 square root of 3. Cool? All right, notes time. Oh, we got to go quick. Oh, shoot. I got this someplace, and it's in a place, the last place I put it, I'm sure. I'm giving you a portion. Make sure people over here get it. I'm giving you a portion. And I'm giving you a portion. I need the extras of this back. This is the second page of your notes. Where is... Where's my notes?
We need one more sheet.
One more sheet. Correct. Any other extras, please bring them up to this table up here. And rather than teach it off. Extras. Thank you. Thank you. All right, I'm just going to go through these kind of quick. This is recorded towards the end of the thing, so if you want to take a look at it. All right, so the first two, they want us to factor. So the very first problem, I have 3 terms. Agree? I have this, this, and this. Agree? If you didn't, just look down. This, this, and this. All right, so do I have a number that 6, 3, and 12 all go into other than 1? Yeah? Agree? And is there an X as well? Is there an X or no? Or is that supposed to be an X? Did I write it down right? Okay. So a 3X goes in everything. So that gives me 2 what? X to the third. Agree? And this gives me what? X. Awesome. And this gives me 4. Can I factor that any further? No. Okay, I'd say if this became x squared, then let's try it. But there was just a greatest common factor on this one, which happened to be a number and a letter both. Next problem, I have x squared plus 8x plus 15. Sometimes you can go quickly on factoring it. So what are the factors of 15 times 1? 15, so 15 are 1 and 15, 3 and 5, both positive. X squared plus 3x plus 5x plus 15, yay? What do I have in common here? X. Oh, good. Yeah. X plus 3. And then what do I have in common here? 5. Oh, yeah. Sorry. That's a 5 there. And that gives me x plus 3. So I went from 3 terms to 4 terms to 2 terms. This and this are in common. So I wind up with x plus 3, x plus 5. Done. Cool? Yeah. Yes, but you'll get the same answer. You'll totally get the same answer. Yeah?
So why did you decide to just go with 3x and 5x?
Because I knew that 3 times 5, positive 3 times positive 5 is positive 15, and positive 3 and positive 5 added together gives me positive 8.
Okay.
Cool?
Yeah.
All right. Can I move on? All right. I have x squared minus 16. 12x squared minus x minus 6. We'll go with both those. First one, it's called the difference of 2 squares. Recognize that from algebra? So that just means that you're going to wind up with x plus 4 and x minus 4. So you factored it. Got it done. Good. And then this one. This is one of the combination methods. Okay? So I'm going to go negative 6 times 12. I'm going to wind up with 6 times 12 is 72, I think. So I wind up with an answer of negative 72. So what do you know about your two signs? How do you get a negative number by multiplying two numbers together? A positive and a negative. So I have alternating signs. So quickly, my factors of 72 are this. 4, 1, 32, 5, no, 6, yes, 6 and 12, 7, no, 8, and is 8 times 9, 72? Okay. Which of those two, one being positive, one being negative, would add up to negative 1? Yeah. There you go. And it has to be the negative on the 9. So I'm going to go 12x plus 8x, or 12x, plus 8x minus 9x. So these are what this is going to sum up to, minus 6. What do I have in common between those two? 4 goes into 12 and 8. X is in both terms, so that's 3x plus 2. Because there's a negative here, that means that this has to be negative. What goes into both those? Guys and girls, in your worksheet packets, this is worksheet 0.2. Try the best you can on it. So, and then come Monday, 3 things due. Find my YouTube page and email me. Okay, it's on the back side of your sheet. This is YouTube. Complete worksheet. Is that 0.2? And then we do have a quiz Monday. I am in my office if you need help. Okay? Have a wonderful, wonderful weekend. See you soon.
Quiz Monday?
Yeah, it's on the summer packet.
Okay, and we email you would be fine with Jana?
Yeah, so do you have my...
Yeah, it's.
So my expectations on the back side of it, it's in bold, and it has my email address. So find my YouTube page and just tell me 2 random facts about it. It doesn't have to be specific. Just like, oh, I noticed that the video on this day was watched 3 times or something like that, which might change because it doesn't. How do you feel?
So